And we're live.
I made the library and imported all the Git data. I think you muted yourself.
Yeah, I'm muted. Cool. It's the Chist project. The one pulling the, yeah, Chists. I don't know. Oh, you're muted.
Yeah, I'm looking at it now.
Cool. The one from yesterday was, I think it was simple enough. I don't know why it got so confusing. I think we tried to do too many things at once.
I'll get the hang of it. I think I messaged one of the classmates and we're gonna try and work on the project together. Not the project, but the assertion error part.
Good. All right, welcome. For those that are just joining, I have Jordan here with me. He's in Japan. We try to open up the invitation for our current students. So Jordan is the only dedicated one. And I think the time zone helps a lot, right?
Yeah, I was gonna say, don't say I'm just here because I've got nothing else going on today.
All right, so we should get started just to give everybody an introduction. As usual, we will have more people joining late, but we want to keep it on time because we know that for some folks in the East, especially, it's late. And also because, to be honest, we have thought these workshop as a set of activities that you can work with. Of course, we will explain them, but hopefully you can just, like, we can hang out this hangout and you can keep working on that and keep learning on that. And it's going to be a good starting point for those tasks. All right. So hopefully that's how it's going to work. We like to do things as practical as possible. So as much code as you can write as possible. And of course, this is not going to be the exception. We will be writing real code and of course also seeing the tools, right? The tools are an excuse for us to think the algorithms, to think about the data, to give you like real ideas of how that works. If a few, I'm gonna paste it here. A few comments, and I'm gonna do it here only once in our Slack community. If you have any questions, I'm typing as I'm saying this, please post them in. Please post them in. It's workshop questions. It's the channel, and I will keep an eye on it. Because we also have the comments on YouTube, but to be honest, it's harder to keep track of that there. All right. So if you have any questions, just post them in our open Slack community. I'm gonna post the link on YouTube once. Sorry, I cannot find the.
Santa, I think you're muted.
Oh, thank you very much. I've been talking for like 5 minutes. Good thing you're here, Jordan. Thanks, folks. I'm just seeing the comments. All right. It's my bad. All right, let's get started. Again, we try to make these as practical as possible, and we want you folks to be able to take something, out of this. And even if you have to leave in 20 minutes, whatever, you can at least get something going for you to practice later. All right, so that's the idea of these workshops. We want you to start coding and start practicing because it's super simple. So what I said before was the only thing you need is this notebook, this Azure service to create notebooks. You will go to your libraries, you will click on new library, as I showed you before. I'm going to start the process again. And the important part is just to create the library from GitHub, all right? That will pull these already created notebooks we have in this repo. It will pull it into your Azure libraries, right? So the important part here is to put this URL in the GitHub one, and just give it a name. I was doing workshop. Today is March 1st, right? And I'm gonna put BA workshop March 1st, whatever. And you will hit import, and that'll be kind of it, to be honest. It will just import all the code for you, so you can see it out there. We will be using Jupyter Notebooks today, which are, of course, like the main tool to work with data in Python. You've probably worked with something else too. I don't know if you use R or like bigger notebooks or something different. In Python, we use Jupyter Notebooks a lot. And that's because they are really convenient, and they are backed by a real Python kernel, they call it, but it's a real Python compiler, we could say, although it's not a correct name. So you will be writing code in your browser. I'm going to show you that in a sec. You will be writing code in your browser that it's backed by a real Python interpreter behind the scenes. All right. So for today's project, we'll be working with a series of tools. We're going to start just with a quick introduction to Python. And then we're going to go with pandas. We're going to have the activities there. We have real activities for you to work with. And we're going to finish with some matplotlib to show you how to visualize your data. And something we like, our main objective for this workshop is to show you how simple it is to get started. Let's say this already. But we want to show you, like with a few lines, you can have a beautiful chart, with your data. And maybe those things you were doing with Excel, that took you 1 hour every week, you can automate them, and now they are done alone, in a server somewhere, and it just takes a few seconds, and you get an email with a beautiful chart. So how simple it is to get started. Something that so let's start with Python, and again, I'm going to keep an eye on the questions right here. I'm going to use, in general, I'm getting direct messages. There you go. So I'm going to start with Python, and I will try to keep these as short as possible. 5 minutes, even less, 3 minutes. It's almost 9:10. Let's just do 3 minutes of Python, because I want to put everybody in context, because we know, based on the emails we got before today's workshop, that some of you work either in other programming languages or with, for example, we know that some of you are working with Access or with Excel. So just to give you an idea of Python, this notebook will be still here if you want to practice later. This is the problem with today's workshop, right? That we don't know what's the level of everybody, so we cannot keep it. I mean, if we can take too much time talking about these and get half of the attendees super bored, or we can go really fast and get half of the attendees lost. So it's really hard to balance it. But basically, this is also an excuse to show you how Jupyter Notebooks will work. And I'm going to zoom in here. A little bit less. There you go. I'm going to toggle some of these things. There you go. So it looks a little bit cleaner. And what is this Jupyter Notebook? Or what is this name? This is Jupyter Notebook, by the way. And this is, each one of these cells, right, these ones that I'm highlighting, will give you an interface from your browser to a real Python interpreter. So you can do whatever you want in here. You can do something like 2 + 2, use it as a fancy calculator, and it just works. You will learn how to move around with these notebooks, for example, creating cells or moving cells from one to other, duplicating them, all these things, deleting them, or undoing whatever you deleted, So all these things will be familiar once you start working with them. If you have a question, aside from Google it, you can open this magical command let that will show you the commands. So for example, if you want to delete a cell, right? Delete, you will type delete, and it's going to give you the command. You have to press 2 times the letter D, and it's going to delete it. And if you want to, let's say, undo, it's just with the Z key. So I'm going to type it, and there you go. We have our previously created cell. How do you open that magical palette mode? You will hit Command Shift. Yeah, when you know how to type something, but if you stop for a second to think how it actually is, you don't remember. That usually happens. Shift plus the character P, you can replace with Control if you're in Windows or in Linux, Command or Control Shift P, and that's going to give you that palette that will show you or give you quick access to all the commands you can type. These notebooks have two main modes, and I don't know if we have any Vim crazy people here working with Vim every day. I'm more of an Emacs folk. In Vim and some editors, you have different modes, right? So in this case, you will see the cursor blinking right there. That means that if I type something, it's gonna just be added to that cell. But if I hit the escape key, now the cursor isn't blinking anymore. This cell has turned blue. So now if I type a key, I will execute in a command. So for example, if I type the D key 2 times, I will be deleting the cell. So that's a quick introduction to Jupyter Notebooks. Sorry, hopefully it's going to be easier for you to work with. So Python is a dynamic programming language. It's a really popular one. We, of course, love Python and we teach Python. So we are kind of, I don't know, leaning towards the always recommend Python side. But aside from that, if you think about it, it's one of the the best programming languages to learn today because of all the applications that it has, right? So aside from working with data, but because you might say, I'm working with data. This is mainly my number one task every day, working with data, processing it, cleaning it, analyzing it, etc. All the other applications from Python, and by applications I mean you can do web development, you can do system automations, you can do console-based programs, you can create scripts, you can automate servers, you can work with AWS in pretty much every tool, machine learning. So all these other applications are, of course, really important to keep them in the same language. If you are working with a programming language for data, let's say 90% of your time, and at some point you want to, I don't know, publish your results. You want to publish your results to the world. If you need to switch to other programming language, that, of course, is going to not be really convenient. So in this case, having the option to just keep working with Python is really cool. So Python dynamic programming language, it's pretty much whatever you all might know already. If you know any other programming language, you have the most important data types like integers, floats. We have this decimal type, which is important. We also have booleans, right? We have also this none type, which is kind of the null value in other programming languages. And finally, we have the most important types of collections. And here's probably those things we'll be working with. And these types of collections are basically a sequence type, this list, and we also have a mapping type, this dictionary. This mapping type is like a hash table or a hash in Ruby or an object in JavaScript. And a list, it's like an array in other programming language. And they work pretty much in the same way. These are immutable. By default, in Python, every collection is going to be heterogeneous. So you can put whatever you want. In this case, I'm just putting characters, but I can put none, true, 3, another list. I can make it as complicated as I want, and it works as expected. So any collection in Python is going to be heterogeneous. You can put pretty much whatever you want. And we will draw a parallelism with pandas, with the collections that are provided by pandas. That, as we will be pointing out whenever it makes sense, they will also be backed by another library, which is NumPy. And they also have their own types of collections. So we will be working with all these mixture of libraries and collection types in this workshop. So any questions? How are you folks doing? Good. All right, so let's get started with pandas. And By starting with pandas, we will practice Python, and by working with pandas and Python, we will start seeing details, like, for example, those NumPy things that I told you about, etc. So we are working with this spreadsheet that you can open. It's public, it's in the repository. And the idea is to show you how we're gonna represent tabular data or the regular data that we work with every day in Python, all right? Because this is intuitive. Let me zoom in a little bit. There you go. Maybe a little bit more. Yeah. So this is intuitive. It's a simple way of saying things. And it's the way we usually work, right? We start thinking about an Excel spreadsheet. It's pretty much the same, the first part or the first way of thinking or approaching a data problem. So let's start with series. Pandas series are pretty much the cornerstone of pandas. You will see that other pandas collections will all be backed by series too. And this is a series. This is how you create a series, and I'm going to execute this line so you see it run. There you go. And it looks a lot like a Python list, right? So these, I'm just creating a few numbers, and whenever I was creating the list up here, I was using square brackets, and I was just putting a sequence of values. In this case, I'm creating a series which contains, in this case, a list. This is a regular Python list that has all the temperatures in San Francisco registered from January 1st to January 7th, right? So all these values are here, 7, 10, 11, 11, 12, 9, 8. Now, this series, when we create it and you see the type or sorry, the output created by pandas in work with also Jupyter notebooks, you will see there are a few more things happening aside from this list. And this is usually the main source of confusion for people, especially what we see with our own students. This is the #1 confusion that we get when working with pandas. When we think about series as being linear data or sequence data, like in this case, we're forgetting the most important trait of a series, and it's that each series or each series value will have an index. So I zoom in, an index associated. So in this case, as I'm creating a series only with values, pandas is assigning these indexes directly to the series. And you can think that this is the same way as with, for example, a Python list, because a Python list, once I have created it, I can access, for example, the first element with the index 0. So behind the scenes, Python is assigning 0, 1, 2, 3, right? So this is also happening for a list. So up to this point, this thing looks a lot like a Python list, but there will be one extra change we will make that will separate it a little bit from what we know with lists and hopefully minimize that source of confusion. So let me create a series and assign it to a variable so we can handle it later. What you will see here is that when we have a series created, it will have a type associated, right? And that's what I'm showing you right here. And this is where NumPy is doing its work. Behind the scenes, a pandas series is backed by a NumPy array. NumPy, we don't want to get into it because it's a little bit more complicated and advanced. And to be honest, we don't need to deal with that right now. We can just work without issues. NumPy is an efficient library that will make number processing really efficient. It will be backed by compile code, C code. So whenever you are, for example, working with integers, you're not working with Python boxed integers, which are heavy, overloaded with Python stuff. They are not regular numbers. These are full Python objects in this case, right? These are full Python objects. In this case, when using series, they will be a lot more efficient because, again, they are backed by NumPy arrays. And that's why when we are creating the series, pandas is deciding the type with NumPy. They are deciding the type that this series is going to have. So in this case, as they are saying all integers, they are assigning the type integer 64. And these will change depending the computer or the environment that you're working with, right? So you will see different outputs here. If I put, for example, one of this being a float, and these are annoying. There we go. If I put a float, only one float here, you will see that pandas is going to change the type to float 64. And when we see the representation, it's no longer just 7, it's going to be 7.0, which is pretty much the same thing when we're doing our work, but there will be differences, and sometimes it's important to understand it. So that's enough. We have this series, which it has an index, as we know, with Python. It has a type associated that it's worked in with also NumPy. And why are we using this series and we're not using, for example, a Python list? Well, the NumPy array addition is pretty good. And also you will see that these series will have a lot of convenient methods that regular Python lists don't have. So for example, just one of them, and we will see, for example, more broadcasting operations and mask arrays, etc. For example, if you think about this thing as a vector, as a mathematical vector, you might think about the operation of multiplying a vector by a scalar, right? And that operation, if you perform that operation in Python, if I do this with a Python list, what you get is 3 times the same list, which of course is not what you're expecting. If you perform the same operation, the times 3 with a series instead of a list, what you're getting is the real result that you're expecting, which is multiplying, in this case, a vector or an array with a scalar, right? So that's what we're expecting. And I'm just putting this as an example, and we want you to see how powerful it's going to get later. So something else we can do is we can name a series. So I can put a name here. And now this series is going to have a name associated. It doesn't make a lot of sense now, but when we work with data frames, the name will be the name of the column later. For now, that's enough. But most importantly, and this is where the confusion is going to hopefully be solved, more importantly, a series can have arbitrary index decided by us that are not just integers, right? So again, when we created this series, Pandas was creating an index automatically, a numeric index to each one of these values. And that was, up to that point, we were pretty close to a Python list. But actually what we can do with a series is assign an index that is not numeric and it's decided by us. So in this case, I am providing these 7 values, and I am also providing the 7 indexes for each one of those values. And of course, these are matched by order, right? Monday is going to be 7, or actually 7 is going to be indexed by Monday, and 10 is going to be indexed by Tuesday, etc. And when I create this, there you go. Now this thing looks a lot like our previous table. So if I paste this thing, Monday, Tuesday, Wednesday, etc., it's pretty much the same thing. So now what you see, or what we might think, is that the series, they are not so close or so similar to lists, but they are more similar to actually dictionaries, right? And this, again, is a big source of confusion. Hopefully, if you start thinking about them differently, it's going to make a lot more sense. So a series, it looks a lot more like a dictionary than what it looks like a list. It has the advantage, if you want, that things are ordered and they are sequences too, because we have 7, 10, 11, 11, 12. Dictionaries in Python are not ordered, so the order is going to just be lost when you create them. A series will keep them, but again, the indexes they can be whatever we want. They can be dates, for example, if you work with financial data with time series, they can be dates, they can be time deltas, they can be, in this case, strings, they can be whatever you want, and that's pretty convenient. So again, it looks a lot more like a dictionary. Usually in a dictionary, we call these keys. In Pandas series, we'll call them indexes. So let's speed up a little bit. Whenever you have a series created, you can access the values, and this is going to be an NumPy array. It's going to be the type of these. Well, it's going to tell me array probably. There you go, NumPy array. And you can also get an index, right, which will give you each one of the values one after the other. Something also neat of series is that, and I'm going to put it above these, is that they are, I mean, this is Pandas, this is NumPy. It's, of course, thought for scientific processing. And in this case, you have all the basic mathematical operations that you want to perform. So, for example, you can get a count, how many elements you have, what's the mean of that given series, standard deviation, minimum value, maximum value, quantiles, everything is processed with Pandas. And it's not you're going to be using describe a lot. It's just a simple way to show you how how to put it, the philosophy of Pandas. It's and NumPy. They are heavily inspired by scientific programming. So computing all these things is going to be super simple, and thanks to NumPy, efficient. So all these, again, same thing. You can get them either individually, or you can get them with just to describe, and you can get a good summary of your series. So how are you going to access elements in series? And here we will be using both the analogy with the dictionary or a list. So you had created a dictionary in Python, and you can get an element by using the key, right? The same thing is going to be with Pandas series. So I'm going to use the index to refer to an element. And the object that I'm using before these square brackets is just the series itself. You can, and this is important, one big difference we could say between a series and dictionaries is that series are ordered, right? So this is an important concept. Series are ordered. So they are also keeping these kind of conceptual order, like 3, 4, 5, 6, 7. So we can use that order to also access elements. So here I can use the index, or I can use the position. I would say index because it looks, I don't want to confuse the words, it's just the position. So in this case, it's 0. And to do that, you will use the iLoc attribute. All right, so you will see both the loc, which is pretty much this thing, and you will also see iLoc, which usually uses the position. You can also use multi-selection to put it in a way, so you can select many things. For example, you can select 3 days, Mondays, Wednesdays, and Sundays, and these, and this. So you can select these 3 things by passing here, not just one of them, but a list of the indexes that you want to access. And what's the result of that? The result of that is another series with the same name, but this is also another Python series that is a Pandas series, sorry, that is created right in place for you to use. You can also access ranges, let's say, and in this case, this notation is super similar to the one in regular slicing with Python. So for example, let's create, so this list, and I do something like L from 0 to 3. And what do I get? What do I get if I do 0 to 3? Somebody knows? I will be getting, I'm going to run it, ABC. I get from 0 to the previous index or the previous value before the number that I pass as the height n. So in this case, you're going to get 0, 1, 2, one less than the limit that I provided. because that limit, that n limit, is never included, right? So this is, you can draw it like this. Very good. With pandas series, that's not the case, and in this case, we will get Monday, Tuesday, and Wednesday. In this case, the n limit is indeed included, so it's a difference. Don't to get confused. Modifying series, you can just, this shouldn't be here. Modifying series, you can just modify it whatever, like in the most intuitive way. We can set a direct value by an index. Log again works in the same way, or you can use numeric positions, right? You can take advantage of negative indexes. I didn't show this here, but in the same way as with lists, you can do -1 to get the final value, 8, right? And you can of course use the same index to to modify the value. So we've set the one in position 2 as 33 and one in position -1. We don't know which position that is, right? It's always the last one. Either we have 1 element or 1,000 elements. It's always the last one. We have set that to 55. And finally, this is also confusing. How will you append an element to a series? Well, you cannot. It's not that simple. Usually in a regular Python list, we can do something like l.append, a new character, for example, a new value and a new scalar. In this case, if you want to add only one element, you need to provide a new series to be appended. So now we have the second Monday, which value 100, and of course we needed to provide an index for that one. It's not required, but I mean, we need to keep it consistent. Good, all right, so I'm checking questions from time to time. So moving forward, we will use these also too, and for our students watching, this is going to be also similar to functional programming. The idea is that pandas is going to allow you to perform really good operations. I don't know how to mention it without going to functional programming. But it's basically applying different functions directly to each one of the values. So we have, again, the same series as before. And what I'm going to do is apply this function right in place, which I could have defined somewhere else, of course. I could have defined, let me actually do it really quickly. This is going to be def to Fahrenheit to far given temperature, and I'm going to return that. There we go. So here I will apply the function in place to each one of those values. So as you can see, pandas is returning a new series, right? If I show you the previous temps, it's not modified, it's creating a new series, and it's applying these functions that I had defined for each one of the values that we have right here. And this, again, it's super convenient. In this example, it's just doing pretty much the same thing, but it's passing the function right in place. I think these, let me remove these two, make a little bit more sense. And please, if you use these, make sure that you're passing the actual function and not invoking the function. We're passing the function directly. All right. I think it's enough with simple series. We're going to get into a little bit more interesting things. Oh, we need to talk about masked arrays or Boolean arrays first, but it is going to be cool enough. So we're back again to our previous temperatures set in this table, and pandas has a really neat, pandas, not just pandas, NumPy too, a really neat way of letting you filter data, all right? It's going to be super simple to filter data based on different criteria. But there is one big criteria, the most important one, and it's the source, the father, the grandfather of every selecting or filtering criteria, which is the Boolean array. Given a series, you can provide another array saying which values you would like to take and which values you wouldn't like to take. So I'm going to use for those values that I want to take, want to keep, I'm going to say, and I don't want to keep, I'm going to use an X for those that I want to keep, and I'm going to leave it blank, or I'm going to put a dash for those that I don't want to keep. All right, so all the ones marked with the X are the ones that I want to keep. And in this case, I want to keep Monday, I want to keep Saturday, and I want to keep Sunday. I don't know why. I need to check that. So I'm going to use those values. 1 second. There you go, I'm back. So how I'm gonna provide that, of course, that X and dashes are not valid Python names. So what I'm gonna use is just a Boolean array. I will provide an array, and by the way, these are all dashes. Dash, 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 there you go. I'm gonna provide a Boolean array with, in this case, gonna be true, it's gonna be true, true and true, and it's going to be false and false and false and false. There you go. So this is the Boolean array that I have created. True, false, 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 4 instances of 4, true and true. And with that, I will get exactly those values that I wanted to keep. Monday, Saturday, and Sunday. And again, they are matched by order. Append series is an order sequence, so it's matching true with Monday, false with Tuesday, so it's not keeping Tuesday, false with Wednesday, etc. So this again is the grandfather of every selection. And why is that? Because pandas and NumPy will allow you to create these arrays right in place, right on the fly. And it's going to make filtering and selecting data really convenient. In this case, I'm going to do temps less than 10, for example. It's a condition. It looks like a simple Python condition. It looks and it reads well. Let's say I want all of you that don't know anything about Python, I want you to reason about this condition. What's going to give you? Give me all the temps less than 10, right? So if we remove these, it's going to be this one and 10. 10 is not less than 10. No, no, no. 9 is less than 10 and 8 is less than 10. So we're back again to all those values that we want. And when you create this condition, what Pandas is doing is pretty much the same process we did. It's going over each one of these values and it's returning, I'm just going to show you, a Boolean array, right, with the values or the result of that condition for each one of the values. So it's going to say temps less than 10 is going to run this less than 10 operation for each one of the values. It's going to do here less than 10. There you go. It's going to run it for each one of these values. It's going to get, oh, no. There you go. And it's going to get an output out. Is 7 less than 10? True. Is 10 less than 10? False. Right? It's going to give you a final result for each one of those. And that's the Boolean result that we have. So if we put everything together, just the regular manual selection using a Boolean array, and that conditions a Plain series return a Boolean array, we can combine these things with these magical filtering statements you will find, or expressions, that is just give me the temperatures where the temperature is less than 10. That's the way you're going to rate it. And it works, of course, as expected. And here, there is no limit. You can put as many conditions in whatever way you want. Give me all the temperatures while the temperature is less than the mean, for example. There you go. So again, there is no limit here, and you can start saying, and describe or just mean. You can start seeing how interesting these might get. You're filtering your data in a super simple way. What was the way of filtering or creating these filters with regular Python lists? Well, you had to use something like, for example, a list comprehension, which is pretty cool, but it's not as convenient as this. Finally, these filters, again, there's no limit. You can put as many as you want, and you can combine them with regular Boolean operations like and or or. And one thing to keep in mind, the only thing to keep in mind, is that whenever you're trying to combine them with these Boolean operators, you need to surround these expressions with parentheses. In other case, you're gonna break. You just put these. That way, it's gonna break. It actually doesn't even work. If I remove all the parentheses, it's gonna break. Questions? If folks are doing well, we will just move a little bit faster now to work with data frames and our real data for today. Let me close these ones. Actually, I will keep them open just in case we have another question. So we're going to work really quickly now with data frames, and then we're going to move with reading data from a CSV file. And in this case, a data frame, it's going to look like these regular, simple, super common table in an Excel spreadsheet, in this case, Google Docs. So you have an a table, right, that has a number of columns, and each one of those values for those columns are indexed, with an index that you're providing. So that's the concept or the idea behind a data frame in Pandas. And Pandas has but it has two main data types: series, the ones we saw, and data frames. And as you will see, data frames are just a bunch of series. It's going to be pretty much this thing. There is a panel too, but it's deprecated, so don't use it. How is this data frame thing going to work? And it's super simple. In this case, I'm creating a data frame out of a dictionary, a regular Python dictionary. So I'm using columns, right, as the keys of the dictionary, and I'm using the values as a list for each one of them. And I'm going to create it, and you're going to see it. I haven't imported it. There you go. And you're going to see it, and it looks a lot like our table right here. We have London, the temperatures from London, New York City, and finally San Francisco. So these are the columns that we have just provided. London 5386, 5386, etc. Now, a data frame, these kind of looks like this table, but we're still missing the indexes. And remember, we need to pass these indexes manually or explicitly. So in this case, I will pass the index when I use the data. So I'm going to use the same data as before, pretty much the same expression as before, but in this case, I'm passing index as another attribute. And I'm evoking that, and now I get the 3 columns that I wanted, and also I get an index for each one of those values. Data frames support the regular describe method, as you folks remember from series, and it also has a new method that it's called the info one that is not available in series, and it basically gives you a general overview of your data frame. It tells you how many columns you have. We have 3 columns. It gives you a quick overview of each one of them, how many values it has, how many non-null values it has, and what's the type that was assigned for each one of them. If, again, you see or you note closely what Pandas is doing, and as you make progress with this work, you will find this more obvious later. Pandas is still working with series behind the scenes, and here you will see that any operation you perform will treat these as a single series. So if we kind of transpose, or transpose is not a good name for this context. If we kind of drive the analogy to the previous one, right? If you keep stacking London and New York here, you end up with, if you have 3 series, right, you end up with this data frame. That's what we're using right here. Indexing, it works pretty similar to series with a big difference. In a series, when you were indexing it directly, you were getting the index. In this case, whenever you're performing this square brackets operation directly on the data frame, you're selecting the column, right? So we are doing these. Actually, we're using San Francisco, I think. So we're getting these column. And the result of these, what is it? I mean, you can guess it already. It's a series, right? So this result, the operation of selecting a view, a single column, it's going to be a pandas series. It has the name of the column and the type right there. You can also select multiple columns, and what's going to be the result? In this case, going to be data frame, right? With, of course, 2 series. And you will see that you can use the lock for indexes, right, as usual. And in this case, it is also returning a series, but you should look at these transposed. You should see it like, I don't know, backwards. Like it's going to be something like Monday, you know, has 7, I don't know, what, 5 minus 14 and 7. You know, it's giving you these values. It's creating like these tiny series. And anything, again, pretty much every result of data frame operations that are collections will be either series, most common, or data frames. Indexing with ranges, again, this is fundamental. This is super convenient for financial data. Whenever you're dealing with time series and you want to select just a chunk of time, is going to be really convenient. From this to this. And I don't know if we will be making it in time to show you time series. There is a notebook for you folks to see it later, but you also can do indexing like 2018, I don't know, 03, 01, you know, 3 a.m., 30, 50 seconds. You know, you can use indexes in this way and it will work, and it's extremely convenient. So again, indexing works pretty much in the same way with one new addition. Aside from the default type selecting columns, you can also pass like a second indexing value. And in this case, you can select both the indexes and the columns that you want to select. So you say, I want to select Monday, but only for these columns. And you could, of course, do something like after selecting these, you could then do what we have here, New York and London. There you go. Oh. There you go. But in this case, you're performing everything in the same operation. Filtering and selection, Boolean arrays, etc., work in the same way. I'm going to filter my data frame and I'm going to ask for all those values that are less than 10. So values that are less than 10, everything in London seems to be less than 10. So if we have somebody in London, sorry about that. Everything in London seems to be less than 10. Everything in New York seems to be less than 10. I think we might have somebody in New York. And San Francisco, beautiful San Francisco, has a few values above 10. So these are, of course, the ones that we're not keeping on 10, right? So again, selection works pretty much in the same way. And this is the Boolean data frame that you're receiving with this operation. Stacking the operations works in the same way. Pretty much everything will work in the same way. And finally, some missing data that we can deal with, right? So we are adding a few more values to our regular tables. We have Monday 2 and we have Tuesday 2. And we can, out of this series, for example, drop all the not a numbers. And here it's a combination of pandas with Python nonce with NumPy none. all different values, but they are all making sense together here. And in this case, whenever you pass values to pandas to add, it will convert it directly to NumPy arrays. So here it says not a number, none, and it doesn't say none. So it's a different. And then you can say drop not a numbers, and it will give you the indexes, right? All those that they don't contain not a numbers. And here, of course, it's tricky. You have to be sure about the operation you're performing, because in this case, for example, we had only one not a number here, and it dropped the entire index. Tuesday 2 is no longer here. And you, of course, are losing these values. If you need them, you might want to filter by, for example, only San Francisco, or you might decide to do something different, or I don't know. At least if London has a value, you want to keep it. So again, it's whatever you want to perform. And in this case, it's working in this kind of horizontal mode by index, but you can also drop not numbers by columns. So in this case, if you look this column vertically, right, we have no numbers here, and we have no numbers here. New York has all the values. So if I pass access equals 1, you will see that New York is the only column that it's kept. And this idea of axis is going to be pretty popular in data frames in general. You know, whenever you're referring to something by index or by column. Finally, let me show you a little bit more documentation. There you go. Aside from the axis, there is one more thing that we use pretty much all the time in pandas, which is the in place call. And it's not just in drop a number, it's going to be many different functions or methods. And in this case, if you check closely, let me close documentation, df is still the original data frame. When you do drop NA, you're creating a brand new data frame. What happens if you want to be a little bit more efficient and you want to overwrite the original data frame? In that case, you will say in place equals true. And this will first return nothing. So the output of this is nothing. And if we check the data frame again, the original one, now it doesn't have those values anymore. You can also use fill NA. You can use fill NA with either, I don't know, regular data or with different methods. So if we can go back again to these and show you the df. If I do df.fill with something, I can fill the numbers with something, or I can use different methods. So for example, forward fill. In this case, let me show you the regular data frame. In this case, these two are not numbers. So in this case, kind of overflowing from top to bottom the values. So this not a number is like 8 is falling over the next element, here 8 and here 8, etc. You also have a backward fill, you know, but in this case, it's not going to work because in this case, 9 is placed in this second to last element. But in this case, we don't have values below, so they are still not numbers. Make sense? Questions? Good, awesome. Let's get to the fun part. Let's start working with, we're gonna skip the advanced ones. I encourage you folks to see the advanced part, also time series, because they are really neat, especially with multi-indexes and time series indexes, right? So what we will be doing is reading a CSV file, all right? And I'm going to show you how simple it is. The repository, your library, the one you have created, has a directory called datasets. Go back into the previous one, right here, datasets. And we have a few datasets. One from Amazon. I think this one was large. Oh no, I cropped it. It has only to 253 lines, and we also have a list of Pokemons, or a table with Pokemons, and you see how GitHub is performing some visualization improvements over our regular data. This is the data. GitHub is just adding a nice table on top of that. And we will be reading this data, right? And that is also backed by this collection, this spreadsheet, if you want to, so we can compare it side by side. So how are we gonna read our CSV? Well, it's extremely simply a one-liner. You will just do, using pandas, you will do .read CSV, and you will pass the location, the path of that CSV. So I'm gonna read it right there. Something happened. This wasn't an error. And I'm gonna inspect the data frame using the head method. Again, this CSV file has 800 lines. So of course we don't wanna get our entire notebook overloaded with Pokemons. We just get head. We can get head of 5. We can get head of 15, whatever. We get a number to see the structure of our data. So whenever you're doing exploratory data analysis, your first phase, you start with these. You import a CSV and you check, the first values to see how it was imported, etc. So in this case, we are kind of duplicating the index because there is a number here. It's like each Pokemon has an ID, we can say, but Pandas isn't smart enough, right? It's not smart enough to realize that there are numbers here and you want these numbers to be indexes. It doesn't want to do anything you're not telling it to do. So what it's going to do, or what we will do, is just set an index, right, to this data frame. We're going to say this column, the path symbol right here, this column will be the index, and put it in place. Remember, in place, so we will just modify the original data frame. And now, and then, by the way, I'm going to change the name. If I do df.head again, I will get that this number symbol is the index. I don't like the number symbol. I'm just going to use ID. And again, I have my ID there as the index. There are a few other things that you can start doing, especially if you start dealing with dates. And again, going back to time series, actually, I've named so many times time series that I should make just a time series workshop because they are super cool. Time series, no, sorry. The second step, usually when you're doing this kind of exploratory data analysis part, is setting the right type of values. And I mentioned that time series because usually the data, let's see if the Amazon data set that we have right here, Amazon. So see, for example, the way it's going to import the dates in these particular data frame. Each data frame is going to, this data set, sorry, it's going to give you a completely different way of formatting the dates. It depends on the way they have collected the data. So making sense of these dates, making sense of, in this case, we're sending, for example, we are saying that type 1 and type 2, they are categories, and it's gonna have a few neat additions later. But after we do this process of cleaning the data a little bit, we will inspect now the types, right? And you will get, these are all integers, and it has a few categories for type 1 and type 2, and we have a bool type for legendary. All right, a few more things. These are just related to the category type. I can get, for example, value counts, right? Nice features that I can perform with the type category. Value counts, we have 112 water Pokemons, 98 normal Pokemons, etc. You can also, in this case, we're going to get a quick describe of this category type, right? How many we have, the top one, the frequency, etc. And of course, this is a nice operation we can perform, kind of aggregated operations by a given column in this case. So I'm aggregating by type 1, and I am getting values for each one of the other columns. And here you will see how this original matrix, this original table got kind of transposed, if you want. And now we have the index. This is the index, is the type 1. And then we have a bunch of columns with the mean of each one of the values that we have right here. So for example, the total or the attack, the average attack of all the Pokemons with bug type is 70. 112 for dragons, and as you can see, the different operations. Of course, you can kind of simplify that call, and you can get anyone. You can get standard deviation. In this case, we're getting the max value for attack for each one of them, and we're sorting the values, right? So it makes a little bit more sense. We have mean before, you can do the same thing. So this is usually the second phase of your analysis, starting to make sense out of the data, start cleaning that data that you're using. We can start doing all this in place. So if you check the operations we have performed, we imported or we read the CSV in one line, and then we perform a few operations. We set the index, we rename the index, we set a few types manually, etc. You can do all that in place with down here with your read CSV type, which if I show you, it's gonna look a little bit scary, but these are all the things you can pass to your read CSV method. All right, so that's why it's so powerful, but also it can be a little bit complicated to read. Pretty much everything works in the same way. We have more selecting. So for example, give me all the Pokemons that are type fire, and the second type is flying, so all those. Make sense? Questions? I'm gonna check the, nope, we're good. All right, Jordan, you fine? I'm gonna give you folks the activities in a sec, so you can just start working or bail as you wish. All right, so let's go directly to our activities right here. And you will now have to work. I'm gonna go back again in a sec to how to create a notebook. We have thought about 1, 2, 3, 4, 5 activities for you to work now. We will, of course, go over the solutions in a second. We want you to do some crunching to find, for example, the strongest Pokemon. The Pokemon with the strongest defined max. The strongest was is defined as the max attack. So in this case, we don't have strength. We have attack, defense, etc. In this case, we have defined here the strongest one as the one with the maximum attack. And find the weakest Pokemon, right? Counterpart is going to be with the one with the minimum defense, all right? So one is working with the max attack, the other one is working with the mean defense. Minimum defense. I don't want you to get confused with the mean. What's the most common Pokemon type? All right, so those with type 1 and type 2 that are not numbers, right? So these, for example, don't count. These other ones don't count either. For those, right, what are the ones that are repeated the most times? So for example, grass poison, 1, 2, 3, 4. We have bug poison, 1, 2, 3, 4. Normal flying, we have more, 1, 2, 3, 4, 5, no, 4, sorry, 6. So the idea is to start counting these repeated types and see which ones are the most common ones. As the solution is that normal flying, you have 24 of them, so we want to help you steer your solution. What are the most powerful Pokemon by type 1? So you kind of worked with the maximum here, where we want you to find the ones by type 1. You know, we've also done this before. And finally, this is really cool, hidden gems. So those Pokemons that are really hard to find, basically. Those Pokemons that have a unique type, the combination of type 1 and type 2 is unique, right? So Fire Dragon, the type 1 being fire and the type 2 being dragon, there is only one. I don't know how to search this with Excel, but there is only one, and it's these Charizard, Mega Charizard X, whatever, right here. It's Fire Dragon. It's the only one of these type. So you need to find those, all those that are unique. So we're gonna give you 10 minutes to work on these in as many as you want or you can in this time. Don't worry if you cannot make it. We will just go over the solutions together. Nice reminder, you need to open the repository. I'm gonna pass it right along here again. The repository is here. There you go. And you can use that repo here too. You can use that repo to create your notebook. All right, so there you go. 10 minutes, try it out, and ask questions if you need help. All right, we should resume, right? Jordan, the recording is going to be available in the same event that I shared before, but I will be posting it later. All right. I'm going to share my screen again, and we're going to get started. There you go. We have right here our solutions. So we said we wanted to find the strongest Pokemon, and that was defined by attack, right? That was the way we were defining attack. And this is simple. I am just going to import pandas and as usual, import the CSV. And the easiest way, usually this is kind of a two-way of thinking about it. Usually when you're in this more exploratory phase, you want to have an idea of what's going on inside. So the first solution, if you want, or the first approach to the solution would be to just sort values, right? And via tag, and find those first 5. So in this case, we see that Mewtwo has 190, and we have a few more, all these with 185 and 180. So once you're visually, you're using your bare eyes to start making sense out of the data, you can think about more practical, more deterministic solutions. These ones will be, of course, the ones you'll be automating later. So in this case, we're just using a condition, right, to filter those Pokemons which their attack is the same. So let me show you. Let's find the max attack, right? The max attack is 190. So we're going to use those Pokemons which their attack is equal to 190. That's going to be our condition. In this case, we have only one. Whenever you're checking for max, min, etc., you might have more results, right? In this case, we have just one. That's fine. Find the weakest Pokemon is pretty much the same thing as before. And in this case, we do have 2 candidates for that answer. Right now, these 2 Pokemons have 5 in defense. What are the most common Pokemon types? And this is going to be interesting. I'm going to reread the data just in case. And what we will be doing to perform these type of operations will be creating new columns that are computed, right, or calculated based on the previous one, on other ones. So in this case, I have a new column created, combined type, which will be just the combination of type 1 and type 2. And this kind of looks ugly, but it shouldn't. It's just a combination of the type 1 and type 2. So let me run it and show you the head of this. And we have grass poison, type 1 is grass, type 2 is poison, and we have this new combined type. And let's just do it. That it's gonna be, I'm sure I can do something like concat. Is there a concat? Concatenation of 2 values. This one, and what do I put? This one? So it's not my thing. So we're kind of doing this thing, right? we're putting a dash just to make it pretty. But we're creating this combined type, right, that will let us filter later. So now, right here, the second thing we want to do is, what I'm going to do is, I'm going to do vf head. There you go. And we could drop numbers, not numbers. I'm just going to use group by to show you how it works. There you go. So here you're going to get this combined type, you know, grouped, and then you're going to get a count of them. So for example, bug electric, we have 2, bug fighting, we have 2, bug fire, we have 2, bug flying, 14, etc. And visually, you might find your answer, which was, well, in this case, we have no numbers. It was normal flying, by the way. One step forward with these could be to kind of filter right here those that are not null, and I could either drop a number or I can filter them, right? So these, and I did it before this. I'm gonna get this one. There you go. I'm just filtering those that are not null, and I'm doing the same thing as before. I'm getting the combined type, and I'm getting a count for each one of them. In this case, you can see that there's not missing parentheses. Yeah. Oh, what happened? df at. All right, I have one parenthesis missing. There you go. You can see that we have the combined type, and of course, all these values are the same as before. That's it. So then the only thing we need to do is sort these values. Sort values. I have the panel here. Sort values. I can use any column, to be honest. Name, attack, defense, because they are all the same. And I'm going to use name, ascending. I'm going to show you the first 5. So normal flying, we have 24. We have grass poison, 15. Bug flying, 14, etc. We can, of course, get the first one, and that's it. What are the most powerful Pokemons by type 1? We kind of show you how to perform these group operations before. So we are grouping by type 1, right? And I'm getting the total for each one of them. That's the way we generated these this table. And now what I'm going to do is use this transform function. And this transform function, what it's going to do, I'm going to show you the df head again. It will put, so first of all, it's going to find the maximum value provided by that. So we grouped by type 1, right? So these total, and we got the max for each one of them. You know, 600 for bug, 680 for dark, 780 for dragon, etc. What this transform is going to do is it will apply to each one of those types. Let me get a few more values here. The corresponding max value for that group. So it's going to get, for example, Bulbasaur, which is grass poison. The total of Bulbasaur is 318. But it's going to find the total of grass poison and it's going to put it right there. So here, if you check again, combined by type 1, it's not grass poison, it's just grass. So here by grass, we have it right here. It was 630. So that's the value it's going to put here. To each row, it will find the value corresponding to that group, to that type, which is the maximum, and it's going to add it to the row. And we're going to have a bunch of repeated values, and that's fine. That's actually what we need. So for example, Charmander has 309 as total, but we know that the fire type, the max value is 680, so we're going to have 680 in all the fire types, etc. So now, finally, having this result, right, is as simple as performing right here this operation. So by type, we get the most powerful ones, right? So that's, where is it? Most powerful Pokemons by type 1. So here again, we're kind of getting a transposed answer. We get bug, right? And which one for that type is the most powerful one? And we're getting the first here because it can get pretty crazy if you use multi-indexes with many values. But in this case, we're getting the first one for each one of those types. And finally, we have these hidden gems, which are those Pokemons which you will, which are not repeated, basically. The combination of both type 1 and type 2 is not repeated. So here I'm going to reread the data, and I'm going to create again that combined type, these one that we have right here. And what I'm going to do is drop duplicates. Drop duplicates, this method, what it's going to do is I'm going to df dot head, let's do 10. Yep, there we go. Actually, I need just 5. So I want to drop duplicates because I want to find, so if I drop every row that it's repeated, I will end up with those rows that are not repeated. Duh, right? Obvious. But that's going to give me the answer. If I drop every row that I know it's repeated, the result or the resulting rows will, of course, not be repeated. So if I can use this drop duplicates method, right, on combined type, I'm going to just run it without that parameter. But what you will find here is that it will keep the first one. So Bulbasaur grass, poison 318, that's the first row that it finds with grass poison. And from now on, every other row, it's going to be dropped. So the first one is being kept. But we cannot use this answer because we need those that are never repeated. So in this case, the drop duplicates method has a few other attributes that you can pass. Let me open the documentation. There you go. So this keep parameter is the important one. You can keep the first one, the default. Bulbasaur is being kept. The last one, or false, and false will drop all those rows with the given parameter to be passed duplicated. So when I do that, I'm going to use unique df now. You will find that these Pokemons, Fire Dragon, Electric Dragon, Fire Rock, they are only found once, right? So for example, here, Electric and Ghost is found only once. So let me duplicate this one, and we said, what did we say? Grass poison, for example. Grass, right here, grass poison. There you go, we have a bunch of these. But for one of our results, which one? Electric Ghost, we have only one. Make sense? Questions? Good. All right, let's move really quickly over visualization, something that I really like and I don't want to leave aside. and you can check the other notebooks on your own later. And we have the activity here too. All right, let's see if we can make it. So matplotlib. There are many libraries to create charts, plots, graphs in Python. Matplotlib, Boki, there are many. Seaborn. Matplotlib is probably the grandfather of all these others, and it's a really neat one. It's been around for a long time. You can create pretty much anything. So you will see from this image right here the variety of charts that you can create, right? And it is a really popular one. So there is a lot of documentation, flexible, and it creates nice charts. The only drawback, not the only, but the biggest drawback is that it will create only static images. So it creates, for example, PNGs. You cannot, it's not that simple to get it interactive, right? So you've probably seen something like D3 in JavaScript, which is interactive, right? In this case, Matplotlib will just give you a PNG file or a SVG file, whatever, with a static image. The other big drawback that it has is that it by default, it has an awful API, and I'm going to show you that in a sec. So to get started, you will import all these things as usual. I'm importing pandas, I'm importing NumPy too, so I can create this array for testing, and I'm importing matplotlib.pyplot as PLT. And we're including these Jupyter notebook statement that will tell it to, whenever it finds a plot, it will display it in line, right? It will display it right here. So then I'm creating some data. I'm going to show you X. I'm going to show you right here Y. There you go. And those are our plots. So we have X and we have Y that is going to be X squared. And as I told you, big drawback of Matplotlib is that by default, it has an awful API. The way you communicate with a library is its API, application programming interface. I think I might be inventing a new word here, but I think it's application. And the idea is that how you communicate with the library, right? Jordan, can you enlighten us with modules and libraries? But basically what we want to do is we want to kind of black box or access these libraries as like black box, right? And I want to know how it's created inside. So the library needs to expose methods for me to use it. It's like a car. When you get in your car, a car has thousands of moving parts. But how are you interacting with the car? With your key, with the pedal, with the wheel, and that's it. There are a few light switches, and that's it. You know, those are the means or the way that a car is exposing to you so you can communicate with it. The same way we're communicating with Matplotlib with a few functions. And the global API, the default one, it will work as a global object. You will be stacking operations and always modifying the same global plots. And it's really awful, but I need to show it to you so you don't get confused. So what you do is we have imported this whole module, pyplot, as PLT. And what I'm going to do now is plot these two arrays that I have created. Very good. So I'm plotting, right? X is the x-axis, of course, the first parameter. Y are the values that is each one of these x-axis is taking. And here you will see that you will be creating or modifying the same plot. So you're just doing PLT, you're modifying it. We're including a second parameter. There it's the color plus the line type. I'm going to use a red -1. I think I can use, there you go. So you can use different types here for your plots. We can also include labels. And in this case, what you're saying, and a title, what you're saying is that we're using plt, the whole module, dot plot. And then we're using plt.x label, plt.y label. It's a really imperative, old school, Fortran-like API. There is, by the way, we can also set legends. I am setting also a negative, like a negative quadratic function, and I am setting legends here. And to set legends, I'm also using the global PLT interface. I don't know if you folks can see how awful it is. Probably if you're just getting started, you don't realize it. When you start working with this a lot, you find it bad. And finally, a few other types of charts. In this case, we have 2 bar charts. So again, I am plotting everything in this, as everything is in the same cell. I'm creating one chart, and I'm just using the whole module, and it's not really nice. But there is another API, the object-oriented API, which is much nicer. And in this case, what you will be doing is constructing your plot first, or your chart first, your figure first, right? One of these, and then you will be drawing on top of that figure. And that's going to be a lot more convenient and explicit. And I've never done this in Jupyter Notebooks. And this is NF Python, for those you don't know it. Somewhere here it says that explicit is better than implicit, right? This is important. So we are going to create a figure, right? And we will be working and drawing on top of this figure. I'm showing you, let me see if I can. There you go. So for example, I'm just creating one figure, and now I have like a canvas to start drawing on it. And the first operation that we'll perform will be for this set of axes that I have added, because I don't think I will be able to see the figure. I cannot see it. I need to add the axes. But to this blank canvas, I have just added this set of axes, X, Y axis. And now I have these as an object, and I'm using methods of that object. I'm doing axis.plot. I want to plot this thing. I'm drawing on top of this canvas. And I'm going to say set the X label to these axes and set the Y label to those other axes. And then is going to give you the final result. And this means that I could, for example, given a blank canvas, a blank figure, I could add different axes. So for example, in this case, I have another pair of axes. Right there, I can put in whatever I want. And here it's when you start getting these more complicated example from NumPy, you know, like things a little bit more interesting from what we've seen up to this point. So that's the flexibility that it gives you. Instead of just manually creating the figure and adding your axis, you can just do subplots. And it's going to give you the return value. It's going to be a couple, basically, figure and axis. And if we show it to you, in this case, you can create many subplots. Even though usually you will create only one, we're showing you can create many. You're going to say how many rows you have. In this case, we have 2 by 4 columns. The number of columns is 4. And finally, the figure size is just the size in inches of the plot. And then you're going to say, for example, in the figure, in the ax, so you get the reference to all the axes. To the ax in 0, 1, right? 0 row, column 1, I want to put this plot. I'm going to show it to you. There you go. So we have it right here. And then, of course, you can make this, I know, we're going to put it in different ones. In other axes, you can put different things, right? So in this case, I am setting a title for each one of these charts, chart 1, 1, 3, 1, 4, 2, 1, 2, 2, etc. all in this one. But again, basically, what you will be doing is creating a subplot, getting the axes, and start working with them individually. Again, usually you can also just get one subplot of one row by one column. If we have questions, no questions at all. Good. So let's check really quickly the visualization activities. And in this case, we're going to use a different type. We show you bars and a few others. A different type of chart for Pokemon types. So we're going to show you like distribution, if you want, or the number of Pokemons by type. And also a regular bar chart comparing them by attack, as simple as that. So that's the homework for you. And here, right here, you will see how we will be combining data frames with, pandas with, let me, one sec, matplotlib, but I need, am I missing a notebook? I had a summary of the operations you can perform with pandas and matplotlib, but it's not right here, so maybe I dropped it with the new changes. Sorry about it. It's not that complicated. Actually, we have the solutions here. Pandas way of working with matplotlib will be kind of global API. So sorry about it. So let me, visualization, we have it right here. I open these docs all the time. So what you can do is start, you can just get, let me open up these and importing them. And we're gonna run a few examples here. df dot head, just to show you head. We're gonna do, remember you can do something like df dot, and in this case we're gonna do, what can we do, type 1, and we can do tag, for example. And we're gonna get a few. And to any kind of these data frames and series with pandas, you will have the option to do plot. As simple as that. This might not be the final end result that we are looking for. It's giving you by number. We might want to transpose it and use it as a type and sum the types or something. But again, you will, just to show it to you simple, use fixed size here. 16 by 9. There you go. You can see the different attack types. It looks like a mean reversion, right? Actually, yeah, we can. If I show you, well, I'm gonna do it in a sec. So what I want to show you here is just, you can just do plot on a series or in a type. And in this case, we're just gonna use tag because it doesn't make much sense to do type 1. There you go. We're getting different ones. And as you can see, it will, whenever it can, it will give you labels or legends, etc. for your axis. So in this case, what you can see is that we can plot type 1 by the number of values. So let me show you this one right here. There you go. We have 112 are water, 898 are normal, etc. So we will plot this series result because this is the series we'll be plotting. We are kind of performing this whole operation, and on top of that, we're plotting we're saying that the type is a pie chart. So we end up with a distribution of different Pokemons. You can also use size, which did I search group by type 1? I don't know what's the difference. They should be similar. Normal 28. Well, I don't know. The charts look a little bit different. It's really hard to compare pie charts. We shouldn't compare pie charts. But what I want to show you is that these plots with pandas, sorry, are using the global API. So, for example, do we have here yes, we have it right here. So, if you wanted to, for example, give here the mean next to this one, you need to do. So let's get the mean of attack. It's 79. So you need to do PLT from right here. All the imports. Let's replicate them. There we go. So we have the mean, right, of all the attacks, and we are drawing on top the plot. So what's the API that we're using? We're using the global API because we're just plotting on top of the global PLT module, you know, and this is the non-convenient part of using pandas to plot. So the other type of visualization we have, this bar chart. Create a bar chart with each Pokemon type and the max. Let me run it. There we go. And the max attack found for each group. So first we are grouping by type, right? We're grouping by type, and we can get just the max first. It's going to give us the max for each one of the values: attack, defense, etc. by group. But we just care about attack. We're filtering these. We get only attack. And finally, we're plotting that with a type being a bar. And that is the only thing that we're doing. All right, so it's super simple to get started with these plots. I find them even easier or more convenient than working with Excel, to be honest, because once you get used to the API, you know, and to like how simple it is, you know. It's like I wanted to see where was the mean right here. I just added a new line and got the mean right there, and it's simple. Let's just make it a little bit, highlight it a little bit more, and that's it. You know, so this is going to be really convenient for your work day to day. All right, so the other visualizations are right there, and I recommend you to check the time series and the advanced data frames notebooks, especially the multi-index work in here, because it also might be Python 3.6 kernel. It might also be convenient for you. All the transposing, pivot tables, everything in pandas, which is really cool. All right, so there you go. That is it. I want to thank you all. Stream data. Matplotlib with animate the animation module, you mean? There is a mode in Jupyter that will give you the interactive mode, but it's a little bit more complicated, to be honest. And what we've done before is a combination of MoviePy is the module, MoviePy. There is a module that lets you create, I don't know if this is MoviePy or some other one. It's a completely different module that will let you create videos using Python, right? So you can create a video animated. And what we've done is, for example, to create animations with Matplotlib, you can, I don't know, create 1,000 different Matplotlib charts, pictures, right? And combine them all to form the animation. So you will put them with I think it was MoviePy. I don't remember now because it was a long time ago. And you will put them one after one, like frames in a movie, and you will create the animation. This animation module, to be honest, I know it exists, and you have these special Jupyter type, but I haven't used it that much. And if you need to work with like more advanced things, you have to either go with something like D3, or again these MoviePy examples or something similar. Maybe the animation one is more important, but I don't know. Oh, good. Yeah. So Omar has just posted a link to that MoviePy example with Matplotlib. Nice, really cool. Yeah, exactly. But by the way, again, maybe the animation module is way more convenient, but I'm not familiar with it with this. And when we needed it, it was like a year ago, or I don't know when it was, and this was what was available at the moment. So I don't know. You're welcome. So that's it. Yeah. Brady and everybody else, see you later. Have a great night. Oh, we have both Jordans today. Nice.
I didn't know there were two Jordans.
Yeah, what up, dude?
Hey, what's up? Where did you left your hat?
My hat?
Yeah.
Over here, dude. I love that hat. I wear it all the time. I'll put it on right now. Oh.
It's Jordan's.
I just try to put it on over my headset.
There you go.
Good lecture, man.
Thank you.
I love all the Pokemon data. What a fun way, to analyze something, right? So interesting. Because everyone played it,
It's good as well.
It's the best. It's like the best thing you could have chosen. I feel like so many tutorials on it's like some boring like baseball player data or something, right?
Well, there is a big database of sports data. How is it called? I don't remember, but it's paid, but it has massive amount of data, and I've been trying to get my hands on it.
Yeah. Hey, it'd be good for like future remoter stuff, I'm sure.
Yeah.
Yeah.
All right. So goodbye, everybody. Thanks for joining us.
Thanks for having us.
See you, Jordan. Jordan right side, Jordan Japan. See you on Monday in class. Jordan left side. Jordan Chicago. See you. Talk to you tomorrow about that letter.
Good night.
Goodbye, everybody.